Well, if we look at the chain isomerism of the aliphatic amines, it's very simple to understand. The isomerism. So what are we going to discuss here? We are going to discuss about the isomerism of aliphatic amines or aromatic amines. Well, isomerism, the term isomerism and its various classification have been explained in a very detailed and the systematic manner in the previous video lectures of the aldehydes and the ketones. So if you are having any doubt regarding to the isomerism, that you can, I request you to move on to the past video lectures so that you can get it very clearly. But let me give you a glance once more about the isomerism. Basically, isomerism, iso means same or equal, and meros means parts. So suppose there is a compound, there are two compounds, and these two compounds are having the same molecular formula, but something is different there. That means sometimes the chain may be different, sometimes the position may be different, sometimes the functional group may be different. So it talks about the various things. That means the compounds having the same molecular formula but different in its structure, and those compounds are called the isomers, and the process, the phenomenon is called the isomerism. So basically isomerism is a phenomenon in which the compounds having the same chemical formula but differ in its various positions, differ in its functional group or differ in its chain, etc. Well, this aliphatic amines also shows, this aliphatic amines or aromatic amines, anyhow the amines will show the isomerism. So the first isomerism that I have is chain isomerism. So what do you mean by chain isomerism? It's very simple. Well, I have two compounds. These two compounds having the same chemical formula. Two compounds having same chemical formula, but what is different here? Different in its chain. Yeah. So what do you mean by chain isomerism? The compounds, the two or more compounds having the same chemical formula but different in its chain structure. That is called the chain isomerism. So how this amine shows the chain isomerism? Let me show you. Suppose I have CH3, CH2, 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 NH2. This is N-butylamine. So N-butylamine, why? Because 1, 2, 3, 4 carbon atoms are there. So this is N-butylamine. So I will write the same thing but slightly different. How? CH3, CH, CH3, CH2, and NH2. Yeah. So look at here. How many carbon atoms are here? So the name of this compound is, you see, isobutylamine. So now you may ask me that what is the difference between these two compounds? The two compounds are having the same chemical formula, but what is different here? Its chain structure is different. So otherwise, if you are having the doubt regarding to this chemical formula, whether it is same or different, let's count so that it will be clear. How many carbon atoms are there in the first compound? 1, 2, 3, 4. So 4 carbon atoms are there. Similarly, how many carbon atoms are there in this compound as well? 4 carbon atoms are there. 1, 2, 3 and 4. How many hydrogen atoms are there? 3, 5, 6, 7, 8, 9, 10, 11. Similarly, 3, 3, 6, 7, 8, 9, 10, 11. So 11 hydrogen atoms are there. Well, 1 nitrogen atom and 1 nitrogen atom. That means the chemical formula of both the compounds are same. And the name of this compound is N-butylamine and the name of that compound is isobutylamine. So what is different here? The chain structure is different. So here it is a straight chain, but here it is a branched chain because one substituent has been attached here. So by the attachment of the substituent, it doesn't mean that the formula, the chemical formula has been changed. It doesn't mean so. The chemical formula remains same. But what is different here? The substituent has been attached here without changing its formula. So that is what called a chain isomerism. So once again, let me tell you what is this chain isomerism. Chain isomerism is nothing but when two or more compounds are having the same chemical formula but different in its chain structure, then those isomerisms, those isomers are called the chain isomers, and the phenomenon or the process is called the chain isomerism. And these are the examples of a chain isomerism. I think the chain isomerism is very clear for you. Well, let me give you the short example. Suppose CH3, CH2, CH2, NH2. So this is N-propyl amine. N-propyl amine. Well, if I will write this N-propyl amine slightly different, CH3, CH, CH3, NH2. So this is isopropyl amine. N-propyl amine, and here it is isopropyl amine. So both the compounds are having the same chemical formula. Otherwise you can count the number of carbon atoms, hydrogen atoms and the nitrogen atoms. Both are having the same chemical formula. But what is different here? The difference is that the chain structure is different. Here the branched chain is there, and this chain is a branched one because the substituent is attached, but no substituent has been attached here. The chain is very straight. That's why this is called, a chain. That's why these compounds come under the chain isomers, and the phenomenon is known as the chain isomerism. So I hope the chain isomerism is very clear for you to understand. Now let's move on to number 2, that is position isomerism. So what do you mean by this position isomerism? It's very simple. Compounds, 2 or more compounds, we say, let us take the 2 compounds. Compounds having the same chemical formula. Yeah. Compounds having the same chemical formula but differ in the position of NH2 amine. So I think it is very clear to you. It's very interesting as well. Position isomerism. So what is here? If any isomerism comes, you need to understand the 2 things here. What is same and what is different. So the same is very common for all the isomerisms, that is chemical formula. So chemical formula is the same in case of the chain isomerism as in case of the position isomerism as well. What happens here? The chemical formula remains same, but what will be different here? Here the different is that the position of this amine group is different, and that is what basically called the position isomers, and these compounds are called the position isomers, and the phenomenon of this position isomers are called the position isomerism. Well, let me give you the example. Let me show you the example so that you can understand it clearly. Let me write this for you. Well, I have N-butyl amine, CH3, CH2, 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 NH2. So look at here 1 2 3 4. That means this amine is attached in the first carbon atom. If you will count from here 1 2 3 4, this amine is attached in the first carbon atom, right? So one amine, 1 2 3 4. Yes, you can write butane 1 amine, because here in position number 1 this amine group has been attached, but you also can write N-butyl amine. But let me put the position of this amine in some different places. Suppose I have let us see CH3, CH2, CH, NH2, CH2, CH3. Yeah. So if you look at here, in the first compound, here the amine has been attached in the first carbon atom here. So this is 1 2 3 and 4, because functional group is there from right side, that's why we need to count it from the right side. So 1 2 3 4, that means in first carbon atom the amine group is attached in this compound, but in this compound the amine group is attached in the second carbon atom. So what did you observe the difference here in these two compounds? Both are having the same chemical formula, both are having the 4 carbon atoms, here also having the 4 carbon atoms, the first compound having the 4 carbon atoms, similarly the second compound having the 4 carbon atoms. The first compound possesses the amine group, and similarly the second compound also possesses the amine group. So there is no change in its chemical formula. So what's different here? The different is that the position of NH2 is different. So I hope it is very clear to you that when the compounds, the 2 or more compounds having the same chemical formula but different in the position of the functional group, here the functional group is NH2, different in the position of the functional group, then the compounds which are obtained, those compounds are called, the position isomers, and the phenomenon is known as the position isomerism. This isomerism is basically a phenomenon. It's a phenomenon, or you can say it's a process. So this is what the example of the position isomerism has been given you to make you very clear regarding to the position isomerism. Well, if you will slightly change this compound, you will also get it the same. Well, suppose what I will do here, suppose one CH2 will be removed, and here you have written NH2. Of course, here this amine is attached with the first carbon atom, that is 1 2 and 3, and here it is the same thing happens here, that is yes. So this amine is attached to the second carbon atom of this compound, right? That means propane 2 amine. You can say propane 2 amine, but this is propane 1 amine. This is propane 1 amine, but this is propane 2 amine. So what's the difference here? Both the chemical formulas of this compounds are same, but what's different? The difference is that here the amine group is in 1, here the amine group is situated at first place, here the amine group is situated at the second place. That's the difference. Well, this is all about the position isomerism. Let me give you some another examples of the position isomerism so that you can get it very clearly. So the other examples of the position isomerisms are that, suppose I have a ring compound, that is toluene CH3, right? When methyl group is attached to a benzene ring, then what is the name of this compound? The name of this compound is toluene, right? Suppose I have amine NH2. Since this amine is attached to the second number position of the benzene, so this is orthotoluidine. But here slightly it is different. Here this functional group is attached to position number 3. This is metamerism. metatoluidine. Similarly, here this is attached with para, so this is para-toluidine. Yeah. So if you observe it, the chemical formula of all the three compounds are same benzene ring is there, methyl group is also attached there, and functional group amine is also there. But what is different here? The position of the functional group is different. Here the position is at second position, and here it is at third position, and here it is at fourth position. So since here it is at second position, this is orthotoluidine, because when the methyl group, so that means when this amine group is attached to a toluidine, then that is called the orthotoluidine. That is called toluidine. Since it is attached with, it is placed in the ortho position, that's why it is orthotoluidine. Similarly, this is also toluidine, but here the functional group is attached at position number 3. That's why, as per the name, as per the rule, here it is M-toluidine, that is metatoluidine. Similarly, here this amine group is attached at the fourth position of the, hence this is also toluidine, no doubt. But which toluidine? This is para-toluidine. So you can explain giving this examples also of the position isomerism. So I think the position isomerism is very clear for you. The position isomerism is nothing but the chemical formula same, but the position of the functional groups will be different. Well, that's all about the position isomerism of the amine. And now we will discuss about the metamerism. So if we look at the metamerism, the secondary amine basically shows the metamerism. How? You see, the secondary amine means, suppose I have CH3, CH2, NH, CH2, CH3. So what is the name of this compound? The name of this compound is dimethylamine. Dimethylamine, right? Similarly, suppose I have CH3, NH, C3H7, suppose write C3H7. So here C3H7 means ethyl methylamine. Ethyl methylamine. Look at here. This metamerism is very simple to understand, my dear students. Amines can show the metamerism, but specifically the secondary amine shows the metamerism. Why? Look at here. The metamerism takes place due to the difference in the nature of the alkyl group. Look at here. Here both the alkyl groups are same in both the sides of the amine, but here the alkyl groups are different in both the sides of the amine. In both sides of the amine, in the first compound we have ethyl groups, but in both sides of the second compounds, one we have propyl group, another we have methyl group. That's why here the name given propyl. So this is propyl, right? So propyl methylamine, propyl methylamine. So the name is given so. That means metamerism is shown by those compounds in which the compounds having different in the nature of the alkyl groups. Since the nature of the alkyl groups are different in both the sides of the compounds, that's why these compounds, these isomers are called the metamers, and the phenomenon of these compounds are called the metamerism. Well, I hope the metamerism is very clear for you. And if you will look at here, the chemical formula is also obviously, the same. There is no different. You see, because how many carbon atoms are there? 4 carbon atoms are there. Here similarly, the 4 carbon atoms are there, right? C3H7. C3H7. So 4 carbon atoms are there. So C3 and this one C. So 4 carbon atoms are there. Here also 4 carbon atoms are there. So basically the chemical formula is the same. Chemical formula is the same, but nature of alkyl groups, are different. The nature of alkyl groups are different. So this is what all about that we need to understand about the metamerism. And at last that we will discuss about the functional isomerism. The last part of the isomerism. So what is this isomerism called? This is called the functional isomerism. Well, the functional isomerism is also very easy to understand, my dear students. Suppose I have CH3, CH2, CH2, NH2. So what is the name of this compound? N-propyl amine, right? N-propyl amine. So this amine comes under the primary. This is a primary amine, isn't it? Similarly, I have CH3, CH, CH3, CH3, CH3. Similarly, NH, CH3, RRNH, right? So if you will place this methyl group here, let me write it clearly. CH3, CH, NH, CH3. So 1, 2, 3, 1, 2, 3, 3, 4, 5, 6, 7, 3, 4, 5, 6, 7, 9. So if you will look at here, CH3, CH2. Well, so if you will look at this compounds as well, so this is primary and here it is secondary and here it is tertiary. Well, so look at here, N-propyl amine. So this is N-propyl amine. What basically happens here, the number of carbon atoms in both the cases, the number of carbon atoms, you see, the number of carbon atoms in both the cases are same. The chemical formulas of all the primary, secondary and tertiary is also same, because if you look at here, the how many number of carbon atoms are there? 3 carbon atoms. In secondary, 3 carbon atoms. In tertiary, 3 carbon atoms. How many hydrogen atoms are there? 3, 5, 6, 7, 8, 9. 9. Similarly, 3, 6, 7, 8 and 9. So 9 hydrogen atoms are there. If you look at here, 9 hydrogen atoms are there, and in each compounds 1 nitrogen atom is there. So it's very simple to understand, my dear students. That's all about, that is what basically called the functional isomerism. So functional isomerism is shown by all the primary, secondary as well as the tertiary amines. So this is what the examples of the functional isomerism, and these compounds, the compounds having the same chemical formula but different in its various natures, like this is it comes under the primary, it comes under the secondary, since the 2 alkyl groups are attached, and since here the 3 alkyl groups are attached, that's why it comes under the tertiary. But anyhow, however, the functional isomers, these are the functional isomers, and the functional isomerism is basically a phenomenon, or functional isomerism is basically it's a phenomenon or it's a process. So basically what do we understand about the functional isomerism is that the chemical formula is the same. 2 or more compounds having the same chemical formula but different in its functional group. But here the functional group is not so different. Here the functional group, here in all the cases, the amine group is only attached. Here in tertiary amine, in primary amine, but here also, and this is also in primary amines also the amine group is there. Well, this is all about the functional isomers and the phenomenon called the functional isomerism. Well, I think the isomerism part of the amines is very clear for you to understand. Now we will move on to one of the another important part, that is the basicity of amines. before giving you a brief understanding about the basic nature of amines, the last part of the isomerism that I forgot to say you, that is about the optical isomerism. Well, optical isomerism. Optical isomerism, sometimes the arrangement of the atoms are different, and those types of the compounds come under the optical isomers, and the phenomena are called the optical isomerism. So what we need to understand here, this amines also shows the optical isomers, and the phenomenon is called the optical isomerism. Well, how? Suppose I have, say, this is nitrogen and methyl, this is ethyl, and this is propyl, C3H7. Yeah. If the rapid inversion takes place, then what happens? So methyl, ethyl and propyl, C3H7. So what is the name of this compound is basically called? The name of this compound, ethyl methyl propyl amine. So what's the name? Ethyl methyl propyl amine. So this ethyl methyl propyl amine, I have this ethyl methyl propyl amine. Due to its rapid inversion, in this rapid inversion, as well as this is called flipping. So in this optical isomers, the amine has been placed here, but what happens here, due to the rapid inversion, it will be written so, and this is the enantiomeric form of the first one, and this is the enantiomeric form of the second one. That means both the enantiomers number 1 and enantiomers number 2 are obtained. But from enantiomers from 1 to 2, which is obtained, and the process of that is what called the rapid inversion. And enantiomers from 2 to 1 also can be obtained, and that process is what basically called the flipping. So that you need to understand from the optical isomerism. The optical isomerism is not, we are not going to discuss the entire things about the optical isomerism. That's not the part of this chapter. But however, that we need to understand that why, how the optical isomerism is utilized in the case of this amine. This is what I have given you a very simple example to understand how the ethyl methyl propyl amine, due to its rapid inversion, changes into the enantiomeric form, another enantiomeric forms which I have just named here, number 1 and then number 2, and that enantiomeric form of number 2 also can be converted into enantiomeric form of the number 1, and which is called the flipping. So you need to remember here the two important terms, one is the rapid inversion, another is the flipping. Well, this is what all about the optical isomerism. I think the optical isomerism is very clear. So we have completed the entire things about the isomerism. We have done the chain isomerism, position isomerism, metamerism, functional isomerism, as well as the optical isomerism of the amines. Now we will discuss about the basic nature of the amines.